Graphing quadratics. Let me get this paper out of the way. We're not doing this right now. We're graphing some quadratics, guys. Big chapter. Big part of algebra. Big part of algebra 2 as well. Okay, you're going to see it again. You see in algebra, see in algebra 2. This is 8-1. Okay, and this is graphing. F of x equals ax squared. Now I could also say it equals y equals ax squared. Either of those is okay there. Those two things are interchangeable. Okay? And we're going to graph quadratic equations. Okay? Now a quadratic equation, the standard form of a quadratic equation looks like this. Y equals ax squared plus bx plus c. Okay? That is standard form of a quadratic equation. Okay? What makes it quadratic is that squared sign. That's what makes it a quadratic equation. And when we graph it, its graph is called a parabola. Okay? Parabola, not parabola. Parabola. Parabola sounds like a disease. Okay? But it's a parabola. And they're U-shaped. Okay? And they either open up or down. They look like this. Okay? Thus, that's what a graph of a quadratic equation looks like. Now, we're going to talk about the characteristics of it. Okay? Characteristics of a quadratic equation. Okay, characteristics of a quadratic equation. So we are going to start, right from the basics. We're going to break down the different parts of a quadratic equation, and we're going to look at it. And this chapter 8 pretty much breaks down the whole thing. I don't know how fast or slow or what speed we'll go through in this chapter, but we got to start here. Okay, you're going to build a house, you got to have a good base. You got to have a good base. We got to understand this stuff. Okay, some characteristics. Okay, and in this section, in 8-1, we're really looking at f of x equals x squared. We're not worried about this part right here. We're not. Okay, we're really worried about, this is going to be our base graph that we work from. Okay, so let's start to talk about it. So when you have these, okay, it's so important. Like if you graph a line, there's really no points that are that much more important than others. Okay, so if you went to graph a line, okay, you could have an XY chart, and you could have like 0, 1, and 2 and plug those numbers in. Or if you really wanted to, you could plug in 101, 102, and 103. Now, we don't do that because who really wants to go over 103 in graph? But you could. You really could. Okay? No one point is more important than the other. Some people might say, well, your y-intercept's really important. Yeah, the y-intercept's important, but you could live without it if you had to. You could graph points up here and not worry about that y-intercept. With a quadratic equation, this point here is more important than all the rest. Okay, it's really, really important. Okay, it's called the vertex. Okay, the vertex is very, very important, and that's the point where things turn. Okay, that is your vertex. Okay, and so for the graphs that we're looking at for this, x squared. If you have f of x equals x squared, your vertex is going to be at 0, 0. I'm going to tell you that right now. We're going to get into why that's the case later in this chapter. Okay, but for now, that's going to be our vertex, and that's very important. It's the most important point. Okay, now if they had one of these like this, okay, and it was graphed for you, and they asked you what's happening here. Okay, what's happening? And you would say that this is where the graph is decreasing. and then on this side it's increasing. Okay, now I don't think we're going to talk about that too much, but that's what happens. It decreases here and it increases there. Now, and we're always looking as you go from left to right. Okay, you're looking as you go from left to right. So that's why I said decreasing here. Someone can say, well, it's going up here. Well, if you look at it from left to right, like we read, if you read a word left to right, you do a lot of things left to right. It's decreasing here and going up there, increasing, okay? So, when you have these parabolas, there's this magical imaginary line that goes through the vertex, okay? It's a imaginary dotted line that goes through the vertex, and it's called the axis of symmetry. Axis of symmetry, okay? It's very, very important to this, and what it does is it creates a mirror image. It creates so one side is a mirror image of the other side, okay? And we're gonna find in this chapter that it's a pretty powerful thing, okay? It's gonna cut down some of the work that we have to do, okay? Now, the axis of symmetry, the equation for the axis of symmetry, well, first of all, it is a vertical line, okay? It's a vertical line through your vertex. So a vertical line through your vertex, and it's always going to be x equals, because if you remember from algebra, you have the words Xavier and Yahoo, and Xavier means x equals. If you have x equals a number, it's a vertical line, and y equals a number is a horizontal line. Okay, so this is one of my favorite songs. When my kids were little, all right, when my kids were little, we first moved to town here. I grew up in town, and then we moved away and we came back, and we had this thing called Band Hero, and it was like a thing where you could play instruments with the Wii, but it also had a microphone. And the two songs that were popular, there were two Taylor Swift songs. This one is, I believe, the one that Lexi sang. And they would sing. They would say, Dad, can you play my song? I'd put her song on, and she would sing this one. And Callie would sing You Belong With Me. So definitely special song for me. So the axis of symmetry is x equals the x coordinate of your vertex. I'm going to write it here. X coordinate of the vertex. So in this case, with the graphs in this section, your axis of symmetry is going to be x equals 0. Okay? Now, continue down in your notes. I'm running out of room, so I'm going to move the paper. We have to figure out when it opens up or down. And what determines that is A. So, if you remember, okay, this was the original form, and I told you that in this section we're really just worried about ax squared, okay? So, if your A is positive, if A is greater than 0, which means A is positive, it opens up, okay? And A is less than 0, A is negative, it opens down. Okay? So for the graph y equals x squared, that's going to open up. For the graph y equals negative x squared, that's going to open down. Okay? And it's always determined, no matter what, in this section, whether we get really advanced with it or not. Okay, it's always determined on that. Okay, so it's right there. What else? What else do we have with these parabolas? In this section, I think that's probably it. Okay, we'll talk a little bit more. We're gonna do some examples, and then we're gonna talk about when it's narrow or when it's wider. Okay, but let's get started. So, we're going to graph this one here, y equals x squared. So I told you the vertex is 0, 0. Now, we know parabolas look like this. Okay, they look like this, they look like this. So your vertex is here. So you have to pick, to plug in points, you have to pick some x's that are going to be bigger than that and some x's that are smaller than that. some x's that are bigger than that, some x's that are smaller than that. Because you have to pick some on both sides. It's not like a line. If you just picked one's bigger, you might think it was a line. It might even look like a line. So for these, I'm going to pick 0, -1, -2, and I'm going to pick 1 and 2. Now to find the answers to those, I'm going to plug them in, and you're going to see something pretty amazing that happens. Okay, pretty amazing. Let's plug a 1 in. 1 squared is 1. 2 squared is 4. Okay, now let's watch this. Watch this, guys. Ready? So when I plug a -1 in here, watch what happens. -1 squared is 1. -2 squared is 4. So what do you see? Do you see it? Do you see it? My y values are the same. My y values are the same. That's that whole symmetry thing. Okay? Things that are symmetric makes mirror images. So if I think of the capital letter A, well, let's draw it a little bit better. There's a vertical line of symmetry which makes the left a mirror image of the right. Well, parabolas, that's the case. And that axis of symmetry goes through your vertex. So we go over here and I go to 0, 0. And then I go to 1, 1, and -1, 1. Okay? And then I go to 2, 4. And then -2, 4. And I make my vertex. I go make my parabola, go through my vertex. Okay? And then I would do a little dotted line. And my axis of symmetry is x equals 0. It's always x equals a number. And that number is the x coordinate of your vertex. Okay? So, what do you think of that? That's the base graph we're going to use. Okay, we're going to work with that in this first section. We're going to hammer that graph in the first couple sections. And so you're going to know this XY chart almost when you see it. Okay? So let's look at one that's negative. Y equals -x squared. Well, I'm going to tell you right now, the vertex is still 0, 0. Okay, we'll get to y later. Just take my word for it now. And I'm going to plug in the same points. I'm going to plug in -2 and -1. I'm going to plug in 1 and 2. Now, they've got to be symmetric. And the trick with that, the trick with the symmetry, is picking points that are the same distance away from the vertex. So this is 2 units away from the vertex. This is 2 units away from the vertex. They should have the same y values. So if I plug a 2 in, now here we go. Here we go. You got to follow the order of operations. And the order of operations here, the negative is not belonging to that exponent. If they wanted the negative to belong to the exponent, they would write it that way. And they're not. So you have to square it first and then apply the negative. So 2 squared is 4, then make it negative. Put 1 in. 1 squared is 1, then make it negative. Okay, and then we go 0, 0. And then we go 1, -1. And it's going to look the same as the other one. It's going to be a mirror image of the other one. Okay? So there's my parabola. And there's my dotted line. And my axis of symmetry is x equals 0. Okay? So, let's talk about some more characteristics of this. Okay? Because we're still talking about that. Let's talk about domain and range. Okay, domain refers to x values, and range refers to y values. So the x values is like the numbers that you can plug in for x. So I'm going to go over here. Okay, domain, x values. They're numbers you can plug in for x. Range are y values, and they are the answers that you get. Okay, they're the y values, they're the answers when you plug in x. All right. So the beautiful thing about domain for quadratic equations is the domain is going to be all real numbers. Okay, and the range is going to be related to the y coordinate of the vertex. That vertex, there it is again. So you need the x coordinate of the vertex for the axis of symmetry, and you need the y coordinate of the vertex for the range. Okay, and it's going to be either greater than or equal to the value, or it's going to be less than or equal to the value. Okay, so let's look at that last graph that we had up there. It looked like this. So if they ask you for the domain, you're going to say all real numbers. There's no restrictions. You can plug in any x that you want. Okay? So your range, this is your biggest point. That point is called a maximum because it's the biggest y in your entire graph. So that means that your range, the y's all have to be smaller than that point. So y is less than or equal to 0. Okay? So we are hammering this home. Okay? We're getting a good start on this stuff. So now we have to look at comparing. They want you to compare. Compare y equals 2x squared to y equals x squared. Well, y equals x squared, we just graphed it. 0, 1, 2, negative 1, negative 2. And that's going to be 4, 1, 0, 1, 4. Okay, and that's going to look like this. So I'm going to draw both of these in the same graph. So I'm going to make it a little bit bigger, right? Here's 1, here's 1, 1, right here. So we go 1, 1, and then we go over 2 and 1, 2, 3, 4. All right? All right, so there's my graph, y equals x squared. Now, they want me to graph y equals 2x squared. Okay, well, I gotta make a new xy chart for that. Okay, gotta make a new xy chart for that. And then they want me to compare, okay. We'll talk about comparing in a little bit. We're gonna plug in the same point so we can get a good comparison. Okay, now, I plug in 2. I have to square it first and then multiply by 2. 2 squared is 4. 4 times 2 is 8. Still symmetrical, still symmetrical. Put a 1 in. 1 squared is 1, times 2 is 2. And then this point is still 0, 0. Okay? So, let's look. Here's 0, 0. 1, 2. Over 1, up 2. Negative 1, 2. And then 2, 8. So if we look at this graph, right? We look at this graph. Not a great drawing, I don't have any graph paper. Don't cut me some slack there, all right? So this one, comparing it to y equals x squared, is narrower, okay? It's narrower, all right? So we're supposed to compare, right? We're supposed to compare. It's narrower, okay? We're gonna say it has the same vertex, the same axis of symmetry, okay? So that's how we compare. We compare. Now, why was it narrower? Ready? When a is greater than 0, it will be narrower. And when I say a, what I really mean there, is the absolute value of a. Okay? When the absolute value of a is, hold on. That's not what I wanted. All right? Ready? Let's start again. When the absolute value of a is greater than 1, okay, so examples. A is 3, A is 2, A is negative 3, A is negative 2, okay? You're going to have a graph that is narrower than y equals x squared. If the absolute value of a is less than 1, which means it is a proper fraction, okay? Proper fraction means the top is smaller than the bottom, okay? Examples. 1/2. A equals negative 1/3. A equals 2/3. A equals negative 2/3, okay? It's a proper fraction, it's going to be wider. I'm going to show you an example of that. It'll be the last thing we do in this section. I know, it's a marathon section, I know. But we got to get a good base, guys. We got to get a good base, all right? Here we go. Y equals negative 1/2 x squared. And we want to compare y equals x squared. Okay, we're going to compare it to that original. We're going to compare it to the original, okay? So let's look.